to Finding Limits Graphically and Numerically. Today, what we are going to do is really understand what a limit is and how to um, write what a limit is and what the answer is and what you're evaluating. So we're going to start here with some basic notation. We read the words, the limit of f of x as x approaches a is L. Those are the words that we read. That is the English. Here below we have the math. Okay, so LIM, that's short for limit, x approaches a. So the limit as x approaches a. That's written right here. Of f of x. We always have to have an of. Equals will always mean is L. Okay, so I want to notice, or I want to point out a few things. One is the difference between the letters or the numbers A and the number L. These right now I'm using A and L as letters, but these are going to be specific numbers for all of your problems. The number that you put in place of A is an x value. It should be an x value because the variable x is approaching that specific number. And the letter L is denoting a number which is a y value. So this number here in the L spot is the y value, and you will think of that as being the answer to the limit. Okay, one very important concept to point out is that the limit of a function as x approaches a number is concerned about the function near the x value, whatever that number is. It is not the same as what the function is at the x value. We've already learned that. That is simply the y value when you plug a into the x. So if I would plug a in for x, whatever that number is for a, if I plug that into x, then f of a is what the y value is, and then that's pre-calculus and we're done. In calculus, we're not going to care about what happens at the number here, only what happens near it. Okay, so we're going to do an example here. I have a function. The function is sine of x over x, and I'm going to examine the limit as x approaches 0. We're going to do this by completing a table of values, and we've already done some completing table of values in section 3.1, but maybe it wasn't as formal as a whole table of values. So right here, I'm going to put different x values in my top row of my table, and then their corresponding f of x values in the bottom row. And remember, f of x is sine of x over x. So this limit, in this limit, x is approaching 0. Again, I'm only concerned about what's happening near 0, in this case, near 0, not what's happening at 0. So the x values that I plug in should be x values that are near 0, but not x values that are equal to 0. So some x values near 0. Well, 0, let's do negative 0.1. That is very close to 0 and on the left side of 0. But I can get even closer to 0. I could do negative 0.01. That's even closer to 0 on the left side of 0. I'm going to do one more better value on the left side of 0, and that would be negative 0.001. So all three of these x values are near 0, but on the left side of 0. I'm going to do the same kind of thing, but on the right side. Okay, so as you can see, the way I've done these tables, here on the left side, I'm getting closer and closer to 0, which I'm not actually plugging in. And on the right side, I'm getting closer and closer to 0 as well, but I'm not going to be plugging in 0. So now you can get your calculator out, and we're going to evaluate what these things are. Okay, so you can see in my calculator here, I've actually added a graph. And I'm doing that because I'm going to try to do all of these things at once. I'm going to plug in, I'm going to do sine of x divided by x, and the graph is going to pop up here, okay? So you can kind of see from the graph what the answer will be, but we'll talk about that in a second. Then I'm going to insert a spreadsheet, number 4. So in my first column, I'm going to type in those numbers that I plugged into my table. Okay, then I'm going to name these x values as, I don't know, let's name them let's name them A. Let's just name them A. And then over here in the second column, I'm going to have the calculator type all of these into my function. So I think that I can say equals, and then variable f1, enter, and then variable A, enter. And it plugged them all in for me. Okay, so you can now copy these numbers into your table on your note. Okay, so now I've come back over to my table and I've filled in the different values there. Notice if you actually select the box in on the calculator, it will tell you at the bottom all of the decimals, because here you see at 0.001 it's telling me that the value is 1. It is not. There are actually 6 nines and then an 8. They're rounding to 1. They can't fit all of that in the box. So I want you to be sure to actually write all of them that are in there. Okay, so now what is the limit of the sine of x over x as x approaches 0? The answer here is, let's see here, these x values, they're very obviously getting closer and closer to 0. What about these y values? What is the number that we are getting very, very close to? 1. So the answer to the limit is 1. I do want to point something very interesting out here. If I insert um, a calculator page and I try to type in 0 to the function, so f1 of 0, f1, and I'm going to input 0. It is undefined there. There is no value of the function at 0. And this is important to us in calculus because we are not going to be able to find out what the value of the function there, of the function of sine of x over x is at some numbers. However, it's very obvious based on our table of values that the y values are approaching 1. They don't ever actually equal 1, but they're approaching 1. This is what calculus is. We care about what the value is that we're approaching. Okay, the second example is the same kind of thing. I want the x values to approach 3, and you can then figure out what the y values are approaching. So let's talk about some good numbers to plug in there. I want to approach 3. So if I approach 3 from the left, maybe I would plug in something like 2.9. But then let's approach 3 from the left, but do better. So just under 3, but closer to 3, even closer. All right, so this would be approaching 3. We're not actually going to plug in 3. Now let's go just over 3, okay? And this one. I want you to plug those in. Make sure you fill out your table and have an answer for this one, okay? I'm going to move on, but I want you all to do that example now. Go ahead and pause it and figure out the answer to this limit, and I'll be looking for that tomorrow. Okay, next up, we're going to examine limits graphically. And we're jumping ahead of the book a little bit here. We do talk about graphs at this section in the book, but we're going to talk about some other things too. So I have a picture of f of x here. It's a graph of f of x. I don't know what the actual function is, so I can't set up a table of values here. You just have to examine the picture to tell me what the limit is. Okay, so I have two questions that we're going to answer. What's the limit of the function of which you see the graph here as x approaches 5? And then in my second question, I am going to look at the limit as x approaches negative 2. Okay, notice, if you, just going really quickly back to my calculator, the sine of x over x, if you look at this graph, it doesn't look like there's a problem at x equals 0. There is a problem at x equals 0, but if you look at that, it just looks like the y value would be 1. Um, if we zoom in, however, right at this point, well, maybe it's not going to do it. There actually is no value at 0. Let me see here. Let's try something else. Let's trace. And you can see right here at, oops, at, can't grab the point. At 0 it says undefined. Okay, back to, but from the graph, it did look like the y value is just 1. And so when we look at limits graphically, we just look at what the y value should look like it should be. So here is x equals 5 right here in green. I have drawn in where x equals 5. Now, what what is happening in the graph is that we see lots of holes. And at 5 in particular, there's a hole. And let's suppose that this hole is at the coordinate 5, comma 2. That is the coordinate point of the hole, 5, comma 2. So um, notice if I were to ask you what f of 5 is, there would be no value there. F of 5 does not equal 2 because f of 5 is a big old hole. But the coordinate point of the hole is 5, comma 2. So when I ask you for what the limit is as x approaches 5, thank goodness a limit doesn't care about what's happening at x equals 5, just what's happening near it. And so if I follow along this curve, okay, so I'm on the curve, and I am traveling to the right to where x equals 5, then I approach this hole, okay? Now, if I'm traveling along the curve from the right side towards x equals 5, so I'm going left, I'm going down also because the curve goes down. But if I'm following the graph to where x is 5, then I hit this hole again. But what happens here is from either side, the y values, on the left, the y values come up to the y value 2, even though they don't ever get to 2, they come up to 2. And from the right, they come down to 2. And so we do have an answer for this limit. The answer is the y value 2. As x is approaching 5, the y values approach 2. On our next question, however, in our next question here, we're doing the limit as x approaches negative 2. So at negative 2, yes, there's a hole again, but there's also a big old jump in this function. Okay, so let's picture this function as a road. And I am traveling along the left road of negative 2. So as I approach negative 2, right here, here's negative 2. I'm following, since I live left of negative 2, I'm following this road towards where x is negative 2. I end up at, 2. If I approach the left road to negative 2, I end up at 2. However, if you happen to live to the right of negative 2, then you come along this road that is right of negative 2, and as you approach, as you follow the road, and the x values get closer to negative 2, you land at negative 2. That's also the y value here. You land at negative 2. So what y value is the graph tending towards as x approaches negative 2? Well, it depends. If you come from the left side of negative 2, you get the y value of 2. If you come from the right side of negative 2, you get the y value of negative 2. But these are not the same number. This is an example of a limit that does not exist. This limit does not exist because you do not tend towards any one specific y value. And here's where we're jumping ahead a little bit. We do talk about something called a sided limit, which is what happens on one side or the other. And we'll talk about this a lot more in a few sections from now. But what's happening is that the limit as x approaches negative 2 from its left side, I'm putting a little superscript minus sign to denote from the left side of the function. The answer there was 2. And the limit as x approached 2 from negative 2 from its right side. So from the right side, I'm using a superscript plus sign. The answer was negative 2. And since these two values are not the same, my y values do not approach any one value. We're going to talk about that more again later. Next example, I have another curve, f of x. So this is a new example. And so we're going to answer two limit questions. The limit as x approaches negative 2, and the limit as x approaches negative 3. So the limit as x approaches negative 2, right here is where x equals negative 2. Notice that this uh, negative 2 actually has a point on the curve. The point's negative 2, 1. That does not matter, but what does matter is that if I come towards negative 2 from the x values very close to negative 2, x values very close to negative 2 would be these x values that live between negative 2 and negative 3. I come down this graph, and I hit, and my y values come down and they approach 1. From the right of negative 2, I come along this graph, and my y values come up from the bottom of 1, but they do come up to 1. So from both sides, I get 1. Now let's talk about negative 3. In negative 3, something else is happening here. This right here is a vertical asymptote right at negative 3. And as the x values from the left of negative 3 approach that asymptote, they just blow up, and they become infinitely huge. Okay, they never, there's, at negative 3, there is no value of f, but that doesn't matter. What we care about is what's happening as the x values get closer to negative 3. From either side, as the x values approach negative 3, the y values just shoot up as high as they can go. The closer you get to 3, the closer the x values get to negative 3, the higher the y values are. But there is, again, no one y value that they approach. So this limit actually does not exist. Later on, we're going to talk way more about these examples, and we'll say that the limit of this value is infinity. That the limit as x approaches negative 3 is infinity. But for right now, you can just say does not exist because there's no one y value that the x values approach. This is our final example. In this final example, I would like for you to find the limit as x goes to 0 of the absolute value of x divided by x. You're going to want to use your calculators here. And you can do this with a graph. You could graph this on your calculators, or you could set up a table. But I'm going to look to see what you get for your answer. And this is the conclusion of our lesson. Finish this example, and I will see you on Monday.